Hello, hello, everyone, and welcome to Turtlecast. You are here for another episode with a special guest, Avi Loeb, also known as Abraham Loeb. He is one of the world's top theoretical physicists, specialized in his early years on special terrestrial plasmas and then ones that are outside of the planet, did some work with the Israeli Defense Research, and then found himself studying black holes after the fact of catching some object in the sky and analyzing the data. So we're going to dive into it. Avi, thank you so much for joining us here on the show.
Yes, thank you.
Thanks for having me.
So I want to kick this off to start. You wrote the book Extraterrestrial. Fantastic, by the way, and congratulations. I've never written a book. I don't even know what that feat of strength looks like. And not only so much was it the function of looking at data itself and the idea of extraterrestrial civilizations, whether alive or dead, but this was frankly more of a thought experiment in my mind, was the fact that you were actually challenging the psyche of individuals across the globe, ones that are in the scientific community and ones outside of it. And that through that challenge that we can actually reinforce those thoughts, those evolutive thoughts, with data that backs it up. And I think that's fundamentally the most important part, that we can remove the dogmas, remove the biases, and really just observe and analyze what we have found that's directly in front of our eyes. Is that right?
Right. Well, science is a learning experience. It's work in progress, and it's a response of humans to evidence. Science is guided by evidence, not by prejudice, and we've seen it over and over again. The surprising thing is that many scientists are not guided by evidence; they are guided by prejudice, and that's unfortunate because you would expect them to carry that torch of let's pay attention to anomalies, let's discuss them, let's be open-minded. But instead, on many occasions, scientists are guided by maintaining an image and by improving their chances of getting honors and awards. And that's unfortunate, because the way I see science is a continuation of my childhood curiosity. And basically, I'm willing to make mistakes, but that's part of a learning experience. Kids are admirable because they don't care if they get bruised. I mean, they put skin in the game. They learn about the world without prejudice. And why can't we maintain the same attitude as adults? It's really strange. You give adults tenure in academia, and you would expect them not to worry about their job prospects. So instead, they worry about their image, rather than saying, okay, now we are free to think and openly and pay attention to the most unusual evidence that we get. That is not the case. The public is more open-minded, I would say, based on the reaction to my book. And when I decided to write the book, I told the publisher, my main goal is to get a person somewhere in the world excited about science. And if that person decides to become a scientist as a result of reading the book, I will be satisfied. And I got an email a few weeks ago from a woman in Malawi that said that the book is great and I'm thinking of becoming an astronomer. And I told her that would be fantastic if she were to become a graduate student at Harvard, for example. And I encouraged her to apply. And, I'm already satisfied having such emails. I got it from a number of people. Every day I get a dozen of them, of people that are excited. And why would science be boring? There are so many things we don't know. And it's an exciting endeavor to be part of.
You state a really good point. And the way I look at it is the law of squares. And I know you made a quote about this in the book, is that if you've essentially got someone excited about astronomy or physics or astrophysics, you've essentially doubled the thought power towards that specific endeavor.
Exactly.
And if you can double that thought power towards an endeavor that doesn't have ego, it's open, honest testing and going through that path of learning and using data to support that, you've done something beautiful in this world. And they'll share that behavior with their offspring, their friends, and everybody else around them.
Yeah, there is another aspect to it, which is the public cares about the question, are we alone? Are we the smartest kid on the block? And when the public cares about a question, scientists have an obligation to attend to the public's interest, because the public funds science. But instead, a lot of scientists prefer to be on a pedestal, lecturing the public, feeling superior to people that were not admitted to academia. And that's a self-inflicted wound where the academia is regarded as the occupation of the elite. And I find that unfortunate, because the way I see science is like part of life. When, for example, a pipe gets clogged at my home and a plumber comes over, I try to figure out the problem and fix it together with a plumber. And there is no difference between that challenge and being confronted with scientific evidence, trying to figure out what it means.
Right.
Science is a way of life. It's thinking about evidence and trying to figure out how to interpret it and how to make sense of it. Most of the time, we are not sure. It's work in progress. So my point is, the emperor has no clothes. This is how the sausage is made. Most of the time, we are not sure.
Listen, I've been to a sausage factory. It's not pleasant. All right.
Well, scientists should not pretend that they know much more than they actually do. And very often, they maintain a view that is traditional, that is conservative. My point is that extraordinary conservatism leads to extraordinary ignorance.
Sure. No,
Yes.
yeah, it's exaggerated both ways. Go ahead.
Yeah, I had a question. I think one of the main themes in your book is humility. How do you see that, especially when it comes to the scientific community? How do you see humility, a lack of humility? And then what would you view technology as, and what we're working on and moving for the future if we displayed humility?
Right. So let me first explain where it comes in my personal history. I was born on a farm. I collected eggs every afternoon. And I arrived at the academic community as a scientist by a combination of circumstances, that eventually got me to a tenured appointment at Harvard in a non-conventional path. And I always thought about going back to the farm. I don't regard my current position in academia as a great privilege, because being on a farm and being close to nature is more rewarding than having those exchanges with people that try to feel superior relative to other people and so forth. But that was my starting point, and that's why I'm quite different than my colleagues, because of my history. And I've been always trying to help young people, students or postdocs that come from unprivileged backgrounds to succeed in science. 80% of my students over the past decade were women and underrepresented minorities, almost all of them. And there is a reason for that. Many of them just come to me, and I don't need to do extra work. But the other thing I wanted to emphasize is that by doing astronomy, I got a sense of how big is the stage that we stand on. The universe is huge. We are such an insignificant part of it. We can enjoy being spectators, but we don't play a central role. That's the one thing to recognize. The Greek philosopher Aristotle argued that we are at the center of the universe, and that flattered the ego of many people. And for 1,000 years, humanity believed that we are at the center, that there are spheres around us, and that's where the stars are, and so forth. And then Copernicus and Galileo just looked at data and realized that, in fact, the Earth is probably moving around the sun. We are not at the center. And that made a lot of people upset. And they put Galileo in house arrest. But that only maintained their ignorance, and the Earth continued to move around the sun. We know that for sure now. But beyond that, we are not central in any other sense. The Earth-Sun system is very common. Things we find in our backyard exist everywhere. It's around every star. And so, you get a sense of modesty from not having privileges in the universe. We are not privileged in any way. There are lots of systems that share the same circumstances as we have. And also we live for such a short time, just one part in 100 million of the age of the universe. So we are sort of like actors that are put on a stage and without a script. We don't know what the play is about, but we witness only a tiny bit of the play, one part in 100 million. And how dare we contemplate that we are major players in that play? That we don't even know what the play is about. So my point is rather simple. Why don't we check if there are other actors out there? Like see if there are other civilizations. It's the minimum you can do to try and figure out what the play is about.
Well, because
Yeah,
if you don't mind me interjecting,
yeah,
the moment you do look for another actor, and Carl Jung said the same thing, now you actually have a comparative analytic, a data point where you can truly compare a human being and what we perceived as the intellectual pinnacle against somebody else. And they would have to come from another area. And I got to say that a lot of your character, I think, also stems from the remembrance of your grandfather, if I have this correct.
right.
He stood up and he talked back to, the Nazi orators at the time. And he said, no, that's not true. I was actually there while you were actually skipping out on the draft. And if I remember correctly, that's what was said.
Correct. Yes.
That attitude has obviously translated into your life and then into your scientific work, and also the way you've written this book. And it's not something that people are used to because it's so forward, it's so honest that when you call people out, it shakes them up. And if you look at these individuals that are in tenured positions, that do have these 40-year cycles that they go through, that's where the stagnation occurs. It's that conservatism. It's almost like they moved into a position of retirement before retiring.
Exactly.
So we can't really
It-
learn.
it's even worse than that because it's not retirement, it's actually trying to amplify their voice and get honors and awards. And a retired person relaxes and doesn't do much, but many of those people are trying to pursue honors and awards, and they do that by creating echo chambers of younger people that repeat what they say and so forth. But coming back to your very good point, in my book, I discussed the Nazi regime, not just in the context of my personal history and the fact that I exist because my grandfather dared to leave Germany before the Holocaust, but also from the point of view of Winston Churchill, that wrote an essay about the search for extraterrestrial life, how exciting it would be in 1939, and then he was drafted to become the Prime Minister of England during the Second World War. And if we just imagine how how a different reality would have turned out if there was no war. We wasted so many resources, so many people died in that war for no good reason. Nothing good came out of it. We went full circle after wasting huge amount of resources. If the same resources were to be spent on the search for life, if in particular Winston Churchill's essay would have been published and people would pay attention and would use the same resources to search for that, for intelligence out there, perhaps you would know the answer by now. And it just shows you how non-intelligent we are, in the sense of, in two ways. One, we are wasting a lot of resources on non-productive goals, basically fighting each other.
Mm-hmm.
But more importantly, and that was the underlying theme of the Nazi regime, we're trying to feel superior relative to each other.
Yep.
And that's the basis for racism. That's the basis for a lot of academic activities where people try to demonstrate that they are smarter than someone else.
Well, it happened at Harvard with the eugenics studies they did back in the day, and that was readily adopted by the Nazis. And then that carried over into how they looked at Jewish people.
Right. So the point is that it makes no sense whatsoever. First of, most of our DNA is quite the same. And also in the big scheme of things, if you look at the universe at large, all the differences we have among us are really minuscule. They're not significant. So my point is, when you look at the universe and you absorb what it tells you, basically says that feeling superior relative to each other makes no sense. Wasting our resources on fighting each other makes no sense. Let's work together towards a better future. That's what an intelligent species will do. Unfortunately, we don't get that message because we keep, getting stuck in the mud. And by the way, a lot of people say, why think about space? We have a lot of problems at home. Well, guess what? If you focus on your problems at home, you're doing most of the time the wrong thing. If you get a better perspective about the universe, you will behave differently. And it's just like Oscar Wilde said, we're all in the gutter, but some of us are looking at the stars.
Right. Do you know, what you talk about, and congratulations to you for this, and I'm not trying to float your ego or anything. Many astronauts that go to space and look at Earth as a third party, that's when their perspective changes. And lucky for you, for your status of thought that you have, the way you think, your perspective, You were able to garner that by keeping your feet on the ground and actually looking out. And that's a very difficult thing to do. And that takes a lot of self-awareness. And when you talk about bringing us all together and using essentially the macrocosm above us to help us refine the microcosm of who we are as an individual, that will act as our gut check, our guiding principle, using that data to say, hey, let's level some things out here, because this is telling you that the ego is not that important.
Right.
That fighting over a border is not that important. We're saying that someone is different or having to feel superior because that sun is far more powerful. This universe is far more old. And so for you to say that you have all the answers in your average 78-year lifespan on this planet, just looking at that data alone tells you that your perspective is biased, it's skewed, it's not right. It's illogical.
Exactly. And I got this message, by the way, by raising two daughters. When they were infant, they tended to think that they are the smartest and that they're the center of the world. But then when they went to the kindergarten, they got a better perspective about their place. And obviously, knowing about your neighborhood is extremely important. You want to know if there is a smarter kid on the block. And if there is, you become more modest. But you can't pretend to be the smartest without even looking. That's my basic point.
No, and I think it's a fantastic point, but it's not just astrophysics. It's not just black holes. What you're talking about translates into every aspect of all of our lives. The reason anybody could pick up your book and listen to your material or, watch us talking right now is because it translates to them and where they're in their life at this moment. It's something that it's tangible, they can work with. And if you're saying, hey, use the data, slow down, be deductive, be that Sherlock Holmes, observe these things, you can actually elevate yourself by looking at the data. And this is something we are trying to champion. And the fact that you're championing it in astrophysics is something phenomenal.
Well, thank you. But that was the main reason why I wrote the book, and I participated in so many interviews since it appeared, because I wanted to convey this message to the public. My publicist said, the book is a bestseller, you're doing a great job. I said, that's not really my goal. Even if the book would sell 100 copies, my main point is to convey my message. And it's all about that. And, I wouldn't risk getting this backlash from my colleagues if the message was not that important. I think it's important for humanity as a whole, and that's worth all the bruises that I'm getting as a result of what people are saying on Twitter and other social media outlets.
Well, listen, we're here with all the bomb. We'll massage it on you. We'll make sure you're all healthy. You're fine. No one's going to be wailing on you over here. So, and I want to make sure that we don't miss this. I know you've probably talked about it a million times. Can we just talk about Oumuamua for other individuals that don't know who you are? They're listening to this for the first time. We're in over 200 countries here anyway that people are listening to this. So I want to make sure that part of that aspect of the story, that catalyst, is translated.
And can we start September 6, 2017, the significance of that date?
Right. Well, it was October 19th, actually, and 2017. And that's when a telescope in Hawaii called Pan-STARRS on Mount Haleakala in Maui discovered the first object that came from outside the solar system near Earth. And the name that was given to it was Oumuamua, which means a scout in the Hawaiian language. At the time of discovery, the object was already receding away from us, sort of like a visitor that is living out of the front door into the dark street. But there was some data collected on it, and it showed that this object was quite weird, nothing like we have seen before from objects in the solar system itself. The first guess was that it must be a comet, but then we didn't see any cometary tail. There was no gas or dust around it. That was easily decided based on the first observations. And then as the object was tumbling over 8 hours, its brightness changed by a factor of 10. And we saw this object because it reflected sunlight. And a change by a factor of 10 means that the area of the object projected on the sky changes by a factor of 10 as it's tumbling. So it means that it's at least 10 times longer than it is wide, projected on the sky. And the best fit to the variation in the amount of light reflected was that of a pancake-shaped object at a 90% confidence. So you can think of it as a piece of paper tumbling in the wind, very thin and long. And Then this object showed an excess push away from the sun that cannot be explained by the rocket effect from evaporation, because we haven't seen any gas.
Right.
And the only explanation that came to mind is the reflection of sunlight is pushing it. And indeed, the force that was pushing it declined inversely with distance squared, as you expect for reflected sunlight. There was another object discovered in September 2020 that was given the name 2020 SO, discovered by the same telescope, and it also showed an excess push away from the sun as a result of reflecting sunlight, and no cometary tail. But then a few weeks later, the astronomers that discovered it with the same telescope concluded that it came from Earth. In 1966, it was a rocket booster from a lunar lander mission. And we know that it had very thin walls, and that's why it had a large area for its mass, so it could have been pushed by reflecting sunlight. And so we know that we produced that object artificially. The question is, who produced Oumuamua?
That's a I'm gonna test this here for a second, because I've thought about it a lot. You did work with Israeli Defense Research, correct?
Yes.
And when I read it, it sounded to me a lot like a railgun the work you used to do. So I'm going to move a projectile very quickly using electromagnets. I'm just assuming here.
Well, I would. The analogy
you have to share what you know. You don't have.
The analogy is closer to a light sail, which I worked on later on. In 2015, 16. Yeah.
But I thought, if it's a pancake shape and it's flipping over and over and over, it reminds me a lot of a dynamo. So if this object moved through electromagnetic fields, close to suns, close to planets, it's essentially moving its polarity, flips it over and over, creating a charge. And as it would move closer to the sun, this was my thought, that it's actually increasing that charge, which gives it that increase in acceleration that would be standard deviations away from what it should be. That was my thought. Well, if I had a magnet polarized both sides, you see what I'm saying?
Yeah, that's an interesting thought. I haven't explored that.
Well, now we can.
my idea was that it's just reflecting sunlight like a light sail, a very thin piece of material. It could be the surface of a spacecraft that was torn apart,
Sure.
But at any event, nature doesn't make thin films like that. And the main point was whether it's artificial or natural. And, all these weird properties that it had, which I describe in my book, and there are more of them. For example, it came from a special frame of reference, the local standard of rest.
Yeah,
and that's very unusual. Only 1 in 500 stars is in that frame, as this object was. So yeah, there are lots of peculiar facts about it. Perhaps your idea is something interesting to examine. I should say the scientific community. I published it as a scientific paper, and there was a lot of pushback from the scientific community to the artificial origin. But in terms of alternatives, there were 4 suggestions that were made, and all of them contemplated something that we've never seen before. For example, a cloud of dust particles, very loosely bound, 100 times less dense than air.
It's already absurd. It already sounds absurd.
Well, the object gets heated by hundreds of degrees as it gets close to the sun, and such a cloud would not maintain its integrity given the very low material strength. There was a suggestion maybe it's a hydrogen iceberg, a chunk of frozen hydrogen, and then when it evaporates, we wouldn't see the cometary tail because hydrogen is transparent. The problem with that is that hydrogen evaporates very quickly, and such an object would not survive the journey. We showed that in a scientific paper. Then there was a suggestion, maybe it's a nitrogen iceberg. Again, the size we're talking about is of a football field. And that kind of a nitrogen iceberg can be produced if you chip off the surface layer of a planet like Pluto. The problem with this suggestion that we wrote in a paper a couple of weeks ago is that the mass budget is huge. The surface layer of Pluto is a small component in the solar system. And even if you imagine that you chip off the surfaces of all Plutos around other stars, it turns out that you need more mass, by a factor of 100 more mass than the mass you have in stars altogether. So it doesn't make much sense. No. Then there was a suggestion, maybe it's a piece of debris left over from disrupting a bigger object when it passes close to a star. And the problem with that is very few objects pass sufficiently close to a star to be disrupted by the tidal force of the star. And even if that happens, you usually get cigar-shaped objects, fragments, rather than pancake-shaped. So all of these natural origin suggestions that attended to the anomalies of Oumuamua, all of them contemplated something that we've never seen before. And my point is simple. If it's something we've never seen before, why not contemplate also an artificial origin? And let's collect more data about future objects that are as weird, because we will learn something new no matter what. Even if it's natural, we're talking about factories that make such objects that we've never imagined before. So we should collect data. And the best way to examine the nature of such objects is to send a spacecraft that will intercept their trajectory and take a close-up photograph. Because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book.
Yeah. Then you'd have to time it, right? And it's like, okay, now we know the object's coming. We got to launch this thing right now. So you got to be on point with that. I just thought, in a comical sense, say you were a highly evolved extraterrestrial civilization. You wouldn't want to create something that moves through space that, is actually burning up a fuel. You'd want something that essentially collects into perpetuity. And I think it'd be albeit comical if someone was so evolved that they're like, well, if we're looking at it and it's like, what's the point to life? Why don't we just float around and see everything? So this thing just flips around, floating and just checking. And it doesn't matter where it goes because they're like, we just get to collect information.
Oh, that's interesting. That's an interesting idea. I should say that, most of the junk we find in space will probably be billions of years old, because most of the stars formed billions of years before the sun. So if they had technological civilizations like ours, those predated us by billions of years. So, there could be a lot of debris out there. And actually, it's a much better approach to do space archaeology. Because in the past, we were searching for signals, and that's just like trying to have a phone conversation. You need the counterpart to be alive. We can't have a phone conversation with the Mayans, for example. The Mayan culture is gone, but we can find about it from archaeological digs by finding relics they left behind. And the same should apply to space. We have been using the wrong approach in the past. We were looking for counterparts that are still alive, and there may be a short window of opportunity for that, because the kind of signals we are seeking are similar to the signals that we are producing, and maybe that's a very short phase in the history of technological civilizations. They either die, become dead civilizations, or they move on to technologies that at the moment we don't even notice.
Yeah, I thought about that when I think about SETI. So my uncle works for SETI. And he was originally the Interplanetary Protection Officer for NASA, that OG Men in Black. His name's John Rummel. So when I think about that, and I think about searching for radio noise, or if you're using the 21 centimeter wave, I think it was, for hydrogen before it becomes ionized.
Yes.
Looking back into cosmic radiation, looking for signal. When I think of advanced civilizations, I think that advanced sentience is silence, not so much noise. And I think just looking at how we've developed into more and more noise is actually taken away from our evolution. And I think if you look at something that is evolutive, they wouldn't have pollution like we have with our cars, and they certainly wouldn't have pollution of radio signals.
Well, I completely agree. I completely agree. And I actually wrote a Scientific American essay during the pandemic that I called Social Distancing on a Cosmic Scale. Basically, the idea is that a very advanced civilization might decide not to interact with any lower level civilization because it will degrade their quality of life. So
that's you're on it. Yeah,
they would build a cocoon and just get everything they need inside. And the point is, we can still learn about them because they need to throw their trash out. And we could be just like investigative journalists that go through the trash cans of celebrities in Hollywood in order to find the details about their private lives. So we can look at space trash this way.
Well, I wonder what I'd find in your trash can.
I have a question with, I know in 2022, the Rubin Observatory in Chile is going to be opening up. I was reading. And these large telescopes, what are some of the things that we as humans can get behind? How can we get behind these new technologies? And why is it so hard to get funding?
Right. So that Rubin observatory data set will become eventually publicly available, so one can go through it. Now, they cannot store all the data. There is a huge amount of data. They basically scan the sky and record everything, but they can't really keep all the data on computers. So whatever they keep, it would be wonderful if people would go through it and not just look for the standard astrophysical sources that we are used to, all the transient. Just to give you an example, usually astronomers search for objects that move roughly like comets or asteroids in the solar system at the speed that is, a percent of the speed of light, a very small speed, the tens of kilometers per second relative to the speed of light. But one can imagine that if there are pieces of technology out there that they don't necessarily move at that speed. You could imagine things moving closer to the speed of light, and they could be even smaller. And at the moment, if something would move at a fraction of the speed of light across the sky, the astronomers will just dismiss it. They would think it's a cosmic ray that is hitting the detector or something else unusual. They wouldn't suspect that it's an astronomical object on the sky. And so having the data available for people to look for weird things in it, I think is extremely important. And simply because there is no agenda behind taking the data, it will just be scans of the sky. And of course, there will be the SpaceX communication satellites appearing in the data as well, because they reflect sunlight, and that's a major issue that we will need to remove those streaks of light associated with those. But other than that, it would be a wonderful data set. And the sensitivity of the Rubin Observatory will be much greater than the Pan-STARRS telescope that was used to discover Oumuamua. So we could find one object like Oumuamua every month. And in principle, you can detect such an object on its approach to us a year before it comes close. That gives enough warning to send a spacecraft that will intersect the trajectory of such an object, just like OSIRIS-REx, which was a mission to intercept an asteroid called Bennu. And in fact, it landed on the surface of that asteroid. And they took a sample that will be returned to Earth. So imagine if we were to land on a piece of technology from outside the solar system, we could search for the label "Made on Planet X."
I see. I like that. Made in China, made on Planet X, whatever it might be.
That would be awesome.
And, when we consider those data sets, there's no reason at all. There's no prohibitive reason, because even I'll just give us our own plug. Tartle, we have the ability to ingest any data a person wants to put on there. So if the Rubin Observatory was like, hey, we are low on funding, we do want to get this stuff out there, they have the ability to link up that satellite data and actually share it through the marketplace to everyone across the globe.
No, that will happen. You will just need to know how to use the data. But
correct,
it's not subtle. This is data obtained from a telescope on the ground, right. And that will eventually become publicly available. But I should say, in terms of funding, that's a separate question that was asked before about why is it difficult. Well, the funding reflects the priorities of the mainstream in science, and in this case, in astronomy. And if the mainstream is not embracing this search for technological signatures, then such a search will not get funded. And I think it belongs to the mainstream, because we are currently, for example, just to give you an example, we're searching for the nature of the dark matter. That's most of the matter in the universe. So
right.
There are experiments trying to check if it's one type of particle or another type of particle. There are observations of the sky trying to infer some signatures about the dark matter. And there were hundreds of millions of dollars invested in those searches. And it's a search in the dark, because we don't really know its nature. And
no pun intended.
Right. And the search for technological relics is actually better founded, because we know that we exist. So our imagination is guided by what we know about us. And we know that the conditions on many billions of other planets are similar to what we have here on Earth. So I think it makes perfect sense to invest at least as much money in the search for technological relics. And people say, well, there is no extraordinary evidence, but that was the case with gravitational waves. Before we invested $1.1 billion in LIGO, there was no direct evidence for detecting gravitational waves, because you didn't reach the threshold of sensitivity that is required. But once LIGO achieved that in 2015, the first event was detected, and then after that, a lot of other events were found, and the Nobel Prize was awarded for that. But it required an investment of at least $1 billion before we reached the level of sensitivity where we can find a lot of events associated with gravitational waves. And I think the same way about searching for technological fingerprints of other civilizations. You need to reach some threshold sensitivity and look at the right thing, and why would that be less funded than the search for dark matter? It actually has, more appeal to the public, and it has much bigger influence on society. Any answer to this question? Who cares whether the dark matter is an axion or a weakly interacting massive particle?
Right.
It wouldn't change our lives. But if we know that Oumuamua was a technological relic, it would have a huge impact.
You're exactly right. Supersymmetry, big whoop, right? No big deal. And when I think about this, if you say that this is for the public, well, we've afforded the ability for the public to actually donate towards organizations they care about through the marketplace. So if we listed any of those radio telescopes, whatever it might be, any of those not-for-profit organizations that are trying to do this research and they want to get that information out there, all these people in all these countries across the globe can decide outside of the politics of higher education and everything else that's going on to say, why don't we put our money towards this?
Well,
Why don't we do that?
That would be wonderful. And actually, Joe Rogan had the same idea when I was interviewed on his podcast. And I would be delighted to lead such an effort funded by the public.
We can, no joke, have that set up. Not a problem. We already have structured that into our systems. That's how we view the future. And if you want to champion that, if you want to be the torchbearer, like your grandfather was, like you are, and you wish everybody else would be, then let's do that.
Yeah, I'll be glad to. It's a subject that is very dear to my heart. And, when you speak with me, what you see is what you get. I'm not pretending. I'm not manipulating anyone. And I'll be glad to lead such a project if the funding is there.
That's super exciting. That's the difference between coercion and education. And taking the approach of education is the one that will actually help us. And when I go back to this quote I found in your book, page 126, in case anyone's wondering, you said, with insufficient care, diligence, and applied intelligence, humans have proven themselves all too comfortable with ending the lives of their fellow human beings. And then you continue, we must exercise greater care, diligence, and applied intelligence in the preserving of our civilization. Only in this way can we save ourselves. And so that's the type of empowerment we look for. And the fact that you are saying something like this, massive kudos to you. You're going up against tough communities, very entrenched groups. And the fact that you have such a strong spine and you're so sure of what you're doing, I can't even tell you how much we respect 100%. That. And everybody that listens to this will respect that very, very deeply.
Well, thank you. I think a sign of intelligence for our civilization is for us to work together to make the future better, rather than fight each other, rather than try to feel superior relative to each other. And that includes world politics, superior relative to other nations, to other ethnic groups, and so forth. Instead of doing all this nonsense, let's work together towards a better future that will get everyone inspired. And, that comes together with the message that we should look at the bigger picture, because just imagine them looking at us and saying, oh, look at them, that they don't really worth our attention. They're not behaving very intelligently. So let's try to behave more intelligently. Maybe then they will pay attention to us.
Right. And that's going to take a big part of dropping our egos and admitting to the things that we do not know and stepping up to saying, this is what we do know, and knowing where that line sits, and then coming together, unifying the globe, not in some crazy socialist economic sense or anything like that, just coming together as human beings in the sense of life, preserving life, and then searching for more of it. I think that's where we take those next steps.
Exactly. And that was Churchill's message back in 1939. And so, I think this is the biggest, most inspiring subject that we can use to promote us to a better future. And, the Apollo mission attracted the attention of the public. People were inspired, but that's just going to the moon.
Yeah.
Just think about the change to our society if we were to find that we are not alone, and moreover, we're not the smartest kid on the block, and that if we copy a technology from some piece of equipment on the sky that will carry us 1,000,000 years into our future, instead of developing the same technology ourselves, just think of the implications.
I agree. I mean, look at what Velcro did for us.
Just simple, yeah.
Yeah, it's Velcro, Teflon, fiber optics. Look at what
but
even the ball bearing.
By the way, my point from the beginning was that if you were to present a cell phone to a caveman who's used to playing with rocks, the caveman would say it's just a shiny rock. We should learn from that example and be a little more minded than that,
Yeah, and you have to be open-minded to the fact that there are things that could be outside of your perspective of reality, what you think actually exists. And so it's no longer that shiny rock. It's now something that can actually propel us forward in our evolution as a species.
Exactly.
No, I think that.
I wanted to make sure that we're respectful of your time. What is the best way someone can look at your work? And I know is this your 5th or 6th book you've written?
Oh, actually, well, it depends how you count, but if you count scientific books, it's the 8th.
The 8th book?
So I have another book about to come out in 2 months, and it's a textbook of more than 1,000 pages that is titled Life in the Cosmos. So it addresses the same issues, but as a textbook with equations, and it's geared towards people that practice science. And so together with that, I have 8 books, and I have about 850 scientific papers, and so, more than 150 essays in Scientific American and other outlets. And the last, I should say, the last 12 months were very productive for me because nobody barged into my home office unexpected, and I didn't have to travel to work. And so I could focus on creative work. And that's what I've been doing. Every morning I jog at 5 a.m. in the company of rabbits, birds, ducks, and wild turkeys, and I enjoy it very much.
I don't want to be too philosophical, but it's almost like you're dropping back to your time on the farm, but still being in like the main line.
Exactly, you got it. You got it.
It's all about that state of mind. And so I want to thank you for coming on the podcast. I know we had to generalize a lot of things because there's so much to talk about. There's essentially so much data. We'd love to have you back on. Let's push this forward. If you guys want help with channeling funding from the world into these projects that are so important, we are here to do that. We are here for the evolution of people through data, and data is going to do that for us. So, Avi, thank you again for coming on. And, I'm sure Jason enjoyed this just as much.
Yes, thank you so much. I appreciate it. And I appreciate your humility and your courage.
Thank you. I had a great time. It was a pleasure to work with you.
All right. Well, let's talk soon.